Alright, so this is the last video for the test 2 review. So let's go ahead and get started. We've got some graphing to do. So it says, number 12, find all the characteristics listed below for the quadratic function f of x equals negative 1/2 times x, the quantity x minus 4 squared plus 3. So this is of the form f of x equals a times x minus h quantity squared plus k. And so in this problem, the vertex, notice h here is 4 and k is 3, so it's 4, 3. Remember, it's always the opposite of the number here, the minus 4, and the same as the plus 3. So there's your vertex, which means your axis of symmetry is x equals 4. It's just that number there. And what I would encourage you to do at this point is go ahead and draw the graph. So we're 4, 3, or I should say we're going to draw the graph of, or the vertex, and also the axis of symmetry, which is at x equals 4. So because of this minus, a is negative, we know this thing opens down. And so really we just need a couple more points and we can draw this graph. Alright, so it says, how is this graph different from the parent function y equals x squared? So do we have a reflection? Well, because of the minus, we do have a reflection. It's, we'll just say through the x-axis. That's our most common type. Any vertical or any stretches or shrinks? Well, because 1/2 is less than 1, this causes a shrink. If it had been at like a number like 2 or 3, it would have been a stretch. And then any shifts? Well, because of the minus 4 here, inside the parentheses with the x, we're going to have a horizontal shift. It'll be right 4, and a vertical shift up 3. And so right 4 up 3. The y-intercept, we need to find that by letting x be 0. So we're basically finding f of 0. So negative 1/2 times 0 minus 4 squared plus 3. Well, 0 minus 4 squared, that's negative 4 squared, which is 16. So negative 1/2 times 16 plus 3. Well, half of 16 is 8. It's going to be negative 8 plus 3, which is negative 5. So when we chose x to be 0, y is negative 5. And by the way, the work we just did here, you could just plug this into your calculator, actually the way it is at the beginning here, and it will give you that negative 5. If you find yourself making mistakes when you do it by hand, make sure you're checking it on your calculator. So 0, negative 5 is right here. And that's 4 away, or 1, 2, 3, 4, from the axis of symmetry. So there should be one point on the opposite side that's 4 away. And so your graph looks something like that. The graph is increasing on the interval. Well, it's increasing until x is 4. So from negative infinity to 4. Oh, I'm sorry, yeah, negative infinity to 4, it's increasing. And then once we get to 4, the graph's decreasing. So when x goes from 4 to infinity, the graph is decreasing. All right, let's move on to number 13. says find all the characteristics listed below for the quadratic function f of x equals x squared minus 2x minus 8 and use them to graph the function. Okay, so our vertex here, well, we know with this type we have to use the vertex formula. Well, that's x equals negative b over 2a. In this case, a is 1 and b is negative 2. And so it'll be negative negative 2 over 2 times 1. That's 2 over 2, which is 1. So the x value of the vertex is 1. We need to plug that into the function. It'll be f of 1 is 1 squared minus 2 times 1 minus 8. Well, that's 1 minus 2, negative 1 minus 8 is negative 9. And so the vertex is at 1, negative 9, which means the axis of symmetry is at x equals 1. So let's go ahead and put 1, negative 9 on here. It would actually be about here. And let's draw our axis of symmetry. So again, once we do that, you can see that this graph's going to open up because the a here is 1. So we know it's going to look something like this. We just need a couple of points. Well, the y-intercept's the easiest one to find. If you plug 0 into this 0 squared and negative 2 times 0, that all zeroes out. And you're just going to be left with the 8. It's always going to be this last number here. That's where that y value is going to come from. And actually it's not 8, it's negative 8 here. So 0, negative 8, that's here, which means we're going to have a point 1 away on the other side. And so there's a couple of points. Now normally those 3 points are more than enough. But you can see it would be nice to know the x-intercepts here, and in fact I'm asking you for those. So here's where we let y be 0, which remember f of x is another name for y. We've got 0 equals x squared minus 2x minus 8. And I'm just going to go ahead and factor this. This is something you ought to be able to factor using the AC method. You're going to get an x and x. 2 numbers that multiply to negative 8 that add to negative 2. You're going to get minus 4 and plus 2. So we end up getting x equals 4 and negative 2 when we solve for x here. Remember, I'm just setting x minus 4 equal to 0 and x plus 2 equals 0. And that's how we're getting 4 and negative 2. So when we chose y to be 0, we got 2 x values, which tells us there's 2 x-intercepts, which is not surprising here because you're going to have one on each side of the axis of symmetry. So at 4 and at negative 2. And notice the symmetry, you got 1 3 away on the right and 3 away on the left. And so there's your graph. The domain here is all real numbers. This goes forever left and forever right. Remember, domain is always measured along the x-axis going from left to right. For the range, we go from the lowest to the highest point. We're moving along the y-axis because the range values are y values. So at our lowest point, we're at negative 9. And there is no highest point, so negative 9 to infinity is your range. And then it asks about any maximum or minimums. Well, let's see, we have a minimum here. For this function, the minimum is negative 9, and it occurs when x is 1. All right, and that's going to be it for test 2 review.